Assalamualaikum and hi class. So this video will cover on the part of chapter 1 for process control and instrumentation. Okay, I am Nurul Hazwani, your lecturer for this CHE 239. Okay, for chapter 1 we have 7 sub-chapter. Okay. Consists with introduction to process control, historical and modern control system, part of control system, feedback, feed-forward and cascade control system, on-off control system, proportional, integral and derivative control modes, operation and response of control system, and lastly, advanced control system. So, based on the lesson plan, here we can see that I will take 2 weeks to cover on this chapter 1. So three part of chapter 1 we cover in week 1. Meanwhile, the other 4 part of chapter 1 will be covered on week 2. Okay, now we moving on to the aim of this chapter 1. The aim is to describe the fundamental of various types of process control system used in related chemical industries. So what is the course-learning outcome? Okay, firstly, the student should be able to define and explain the part that form control system, recognize, explain, differentiate various types of control systems such as feedback, feed-forward, and cascade. The third course-learning outcome is explain the on-off, proportional, integral, derivative, control modes. Lastly, explain operational principle and response or tuning of PID control modes. This PID stands for proportional, integral, and derivative. Okay. I think every one of you have been questioning what is the chemical process control. Okay, now I will explain what, why, where, how, when about chemical process control. Okay, for the what term, okay, process control normally used in a continuous production. This process control normally use automatically control the process condition in which a product is made. Okay, why we need this process control? For your information, in a real plant, in a real process, the process itself is dynamic and it's always changing. So we need this process control to stabilize, to control the system so that we can get the desired process condition. Okay, next is when should we use the process control? Normally, this process control is used when there is any deviation of process condition such as temperature, pressure, composition, flow rate, and many more. Okay, next is where. Where should we use the process control? Normally, we will use in a process. So we have so many process involved inside this inside the chemical plant. For example, reaction, separation, heating process. All this process needs the process control in order to ensure the desired process condition is met. Lastly, how we use the process control inside the process plant. Okay, this process control normally will measure the deviation of the process condition and take an action to cater the deviation of the process condition so that that process is stabilized and the process condition, the desired process condition is met. Okay, now we move to the definition of process control and instrumentation. Okay, first thing first, when we go to the, for example, chemical industry, first thing we have to know that inside the chemical industry we have a process, right? Okay, we have so many process like reaction, separation, heating, and many more. So in order to maintain, to control this process, we need the narrow down, we need the process control. In order to make sure this process control is working efficiently, we need the process control and also instrumentation. It's actually this instrumentation done the work for the process control, so that this process control can control the process condition at the desired value. Okay, just now I just give you a rough idea about what happening inside the chemical industry. Now I will explain the definition of each of the terms inside the chemical industry. For example, process first. Process is actually referring to the method of changing or refining raw material to create end product. For example, you want to make a paper. So the raw material is from tree, right? So the process actually is the method changing this raw material tree to the end product, which is paper. Okay, next is process industry. So in general, in a wider view, this process, we have many type of process. So this process also have a few type of industries. For example, chemical industry, oil and gas industry, food and beverage industry, pharmaceutical industry, water treatment industry, power industry. Actually, a lot industry we have in Malaysia. It's not limited to what I list inside this slide. Okay, next we move to process control. Okay, this process control is method used to control process variable. Process variable, we have a few examples like mass flow rate, composition, pH, temperature, pressure. So this process control used to control process variable when manufacturing a product and consists of the process plant and the control equipment. Okay, inside this process control, we have control equipment, and we use to control the process variable of manufacturing product and consists of process plant. So we need to have a process plant, we need to have the process variable, and we need to have the equipment so that we can control the overall process. This process control can be very simple system such as domestic hot water system to the highly complex system such as automatic or refining plant. Okay, first term is process. Process is a method to turn the material into the final product. Okay. Inside a process, we have a manufacturing process. This manufacturing process is including mechanical, electrical, physical, chemical. It's not limited to chemical only. So because manufacturing system is very big and there's a lot of product that we can produce. So it depends on the application of that product itself. Okay. So we have process, and then the process control is used. At first, the process control will measure the process variable here from the manufacturing system, and then we will compare with the required desired product, the requirement of the product itself. For example, we need to have the product with the 99% purity. Okay, so we have to measure does this product achieve to what the desired that we set, the desired value that we set. So if this product is not achieved the desired value, then the process control need to take an action, so that take an action and make a corrective action to the process system, so that the end product will achieve the desired value that we set before. So in order to achieve those desired product value, we need to have the instrumentation like controller, actuator, sensor. So all these device is very important inside the process control system. Okay, the main factor basically, like what I'm saying just now, why we need to have a process control, because the process is dynamic and always changes, right? So those kind of changes will affect the safety. For example, safety of the equipment itself. If the temperature of the equipment go beyond the higher limits, it will explode, right? So the main purpose this process control is to ensure the safety of the equipment, the process. Second, to ensure the product quality, like what I'm saying just now. For example, if there is any changes inside the process, it will cause the desired product value fluctuate, right? That means if we want to produce 50 kg of pepper, but suddenly there is a changes of the flow rate of the raw material, it can cause the quality, it can affect the product quality, right? Okay, next is production rate. Same goes to production rate. If the flow rate of the input or any feed or the temperature of process, pressure of the process is changed, it's not steady, it can cause the fluctuate in the production rate. Lastly, process control factor is reduce energy. We want to use this process control because we want to reduce energy. Why? It can be why this energy can be reduced by using the process control, because sometimes for example, like we want to heat up the water, right? So basically to heat up the water, we only need 100 degrees Celsius. The water need to be boiled until 100 degrees Celsius, right? So if we use the process control and we set the desired product output 100 degrees Celsius, this control system will take an action if the system go beyond 100 degrees Celsius, for example 150 degrees Celsius. So every time the process go beyond that, the power supply will cut off. So the energy will not be wasting, right? Because it will be used in a optimal in order to achieve the targeted value. Okay, what does a control system do? Maintain certain variable within some limits. So certain variable is actually depends on our control objective. So what we want to maintain, for example, if we want to maintain the temperature of the boiling water, so our control system, we will maintain the temperature of the boiling water within some limit that we set. For example, boiling water is 100 degrees Celsius. So next, why we need to control a process? Like what I'm saying before, because processes are dynamic, changes always occur, and processes are not in steady state. So that's why we really need the process control. So there are many applications where part or all of the process has to be controlled. So this is list of the process condition that we can control based on the objective that we want. Normally, we do not have to control all of this condition. It depends on the objective of the control itself. So if like what I'm saying before, if we want to the objective is to maintain the boiling water at 100 degrees Celsius, so the process condition take place is only temperature. Now we're moving to historical of process control. So in the early years, the example of the process control is water clock. So this water clock actually is used to measure the time by the gradual flow of water. So there is a vessel. The vessel is filled with water. That water was allowed to escape through a hole, and the time for the water to escape from the hole is read. So that was how the water clock measure the time by looking to the water flow. Okay, next, in the early stage also we have a steam pressure and temperature control system, speed control. In the 20th century, there's extensive use of sensors start to be used. So in 20th century, the PID control is used, feedback control system technique is used, root locus, and now is a contemporary widespread application. So this process control is used worldwide in the navigation, entertainment, smart home, military, space application, and also chemical process. Okay, now I will explain to you what is the difference between the manual process and also auto process. So by looking at this photo, we can see we want to mix a chocolate with the milk. So if in a manual way, we have to mince the chocolate first, and then we have to stir the chocolate with the milk, and then lastly it will become mixture like this. Okay, for the automatic process, we just have to feed in here the raw material, and then this reactor will do a reactions, and the end product, the mixed product, will come out from here. So now we show the difference between the manual control and also automatic control. From this figure, I think you can directly understand, right? So basically, for the manual control, we have the system to be controlled here, and then we have a device to measure the behavior of this system, and the process operator will monitor the measured value. If the measured value is higher as compared to the desired value that we set before, the process operator need to take an action and do a correction to the, for example, this one, make a correction to the level of power. In our automatic control, same, we have a system to be controlled. The system the process variables inside the system will be measured by the device, and then the measured value will be sent to the automatic control, and this system will be integrated with will be linked to the computer, and the process supervisor will just see the trend and monitor based on the trend. If there is a fluctuation, if there is a fluctuation of the process variable, the controller itself will take an action. So manual control before process automation, it is used before process automation. So people rather than machine will perform many of the process control tasks, seems like in the figure that I showed you before. Control operations that involve human action to make an adjustment are called manual control system. In the previous slide, we can see that if when the sensor measure the deviation of the process variable, the process operator need to adjust, right? To take an action to adjust the level of power, right? Okay. So that was a manual control system. So for the automatic control system, control operation in which no human intervention is required, that one are called automatic control system. So basically for the automatic control system, the control action is automated. All is programmed inside the computer and also will be integrated with the control system itself. Okay, now we move to basic of control theory. So this part you need to really understand. Okay, for example, we have heat exchanger. So heat exchanger, we have a feed in, fluid in. We have also steam in, and we have a fluid out and steam out. So normally, this fluid in is at a low temperature. So the steam in will transfer the heat to the fluid in and cause the temperature of the fluid in to increase. So this one, high temperature. So the steam out here will lose the energy and cause the temperature of this tea here is decreasing. So that was how the heat exchanger working. So we have three basic components of control system, which is measurement, decision, and action. So measurement, the function is to measure the variable to be controlled. So normally sensor or sensor transmitter combination will use to measure the variable to be controlled. Okay, decision, controller decide what to do to maintain the variable at desired value. So that means from the measured variable here, it will go to the decision. So the controller will decide what to do based on the value measured here. Okay, later on I will show in a figure so that you can get the understanding about this. So normally decision, the component that for the decision maker is single control loop, which is feedback control loop, multi-variable control loop, or advanced control loop. Okay, lastly we have action. So the component for action is normally final control element. Final control element is actually control valve, pump, actuator. These devices must take an action based on the controller decision. So the controller will give decision to the final control element to take an action. So now we have terms inside the process control. So this one you need to really understand about this. So we have a process variable like what I'm saying just now. Process variable is the condition of the process fluid, liquid or gas that can change the manufacturing process. So condition like what I mentioned just now is temperature, pressure, composition, pH, and many more. So that one is a process variable, the condition of the process fluid itself. So measured variable is the condition of the process fluid that must be kept at designated set point. So okay, later on I will show inside the figure of this, how this term is used, and also the component that I explained just now. So set point. Okay, set point is the desired value. Just now I keep mentioning about the desired value. So basically in the process control, this desired value, we call it as a set point. So set point is the desired value of the control variable. Okay, next we have manipulated variable. Manipulated variable is the factor that is changed to keep the measured variable at the set point. So the purpose is to keep this measured variable at desired set point. So next we have disturbance variable. So basically disturbance variable is an undesired, unsteady process condition that affect the process output. That means for example like the process condition like temperature, pressure, and composition, and many more. Sometimes the temperature is fluctuate, right? Due to the rainy day or due to the sunny day. So that was a sometimes that this process condition will affect the process output. If the surrounding area, if our area is a rainy day, occurred around 7 days like that, so the temperature of the surrounding area will become low, right? This is example of disturbance that cause the process output to change. Next is error. Error is a difference between the measured variable and the set point and can be either positive or negative. So after we measured the process variable, and then we have to calculate the difference between this MV and also SP. So if MV minus SP, and then that was an error. So offset is a sustained deviation of the process variable from the set point. Next is open loop system, the behavior with no controller in the system. So if the system don't have any if the system don't have any control system, so if the process don't have any control system, we can call that open loop system. Closed loop system is a closed control loop exists where a process variable is measured, and then after the process variable measured, that measured variable is compared to a set point. After compared to set point, it will be sent to the controller. Controller will decide what action need to be taken to correct any deviation from the set point. Okay. So, okay, this one is the figure that I mentioned before. So we have 3 components, right? One is for measure, one component is for decision, and lastly is for action, right? So as you can see here, okay, let me explain back. So the function of this heat exchanger is to heat up the fluid in, right? So if we want to heat up the fluid in, we have a certain desired value we need to fulfill, right? So for example, we want the fluid the temperature of the fluid up here is around 100 degrees Celsius. Okay, basically our control objective is to maintain or to control the fluid out from the heat exchanger to the 100 degrees Celsius. Okay. So first component is to measure. So normally we will measure the T out, the desired T 100 degrees Celsius from here. We measured using transmitter, sensor transmitter here. So if for example this if the measured variable here is around 90 degrees Celsius, and then they will send back if the measured variable here is around 100 degrees Celsius, and then we send back to the temperature controller. So it will compare whether the temperature the set point here is 100 degrees Celsius, right? Because our desired value is 100 degrees Celsius, set point is the desired value of the process variable, so 100 degrees Celsius. So the measured also 100 degrees Celsius, so there is no action need to be taken. So the controller will inform the final element not to do anything. But if the temperature measured here is around 90 degrees Celsius, that means the value measured here is not achieve set points, and then it will send back to the controller. So at the set point at the controller, the set point set is 100 degrees Celsius, so minus with 90 degrees Celsius, so around 10 degrees Celsius is not achieved, and then the controller will send the information to the final elements to add in more steam, so that the system become hotter, right? So that the output here, the temperature going out here achieve 100 degrees Celsius. Okay. Okay. So this one is for the process control term. Okay, just now I got mentioned to you the measured will be taken here. So decision here, action here. So based on the process control term, this one is called as a control variable. So T desired here 100 degrees Celsius This T desired is called as a control variable. So the control variable will be measured. So for example, like what I'm saying before, if the temperature going up here is around 90 degrees Celsius, so the transmitter will read, oh, the temperature is only 90 degrees Celsius. It will send the information to the controller. Controller compare with the set point. Oh, we need another 10 degrees Celsius to achieve the set point. So the controller will give the information to the final control element, and also known as a manipulated variable. So the controller will ask final control element to open up the flow and ask the steam open up the flow for more steam to flow inside the heat exchanger. Okay. Next is a disturbance. So this is disturbance variable, also known as a load disturbance. So sometimes the temperature fit in here in a ideal condition. The water is around 27 degrees Celsius, right? So maybe the surrounding area is rainy around 7 days already. So the temperature here maybe slightly drop to 23 degrees Celsius. So this change of the temperature here cause the effect to the desired temperature, and also known as a control variable here. Okay, so that's why we need the control system to ensure that whatever it is, the feed in, whatever temperature for the feed in, the feed out must achieve the set point, which is 100 degrees Celsius. So normally for this system heat exchanger, the steam out is one of the uncontrolled variable. So please remember all the variable here. So we have here we have Ti, T steam in, T steam out, T out. So all these four is variable. So this variable is categorized as uncontrolled variable because it doesn't give any effect to the system. So the control variable is this variable. So this is the main control objective. The T steam in is our manipulated variable, and the disturbance is the fluid in, the temperature of the Ti fluid in. Okay, now we move to open loop control system. Open loop control system, also called a non-feedback controller. Basically, this open loop control system, there's no control system inside this system actually. So the characteristic for this open loop control system is does not use feedback to determine if its output has achieved the desired goal of the input. That means we cannot determine whether our output achieve our set point or not. This means that the system does not observe the output of the process that it is controlling. Next, do not engage in machine learning. Do not correct any errors, any deviation of the process variable from the set point. Lastly, do not compensate for disturbance in the system. If there is any disturbance feed into the system, this open loop control system cannot do anything. Okay, so this is the figure of the open loop control system. Yes, we have a controller and also actuator inside the process, inside the system. Actually, this one is system, this one is process. So we have all of this, but the control system devices is not complete, right? Because for the control system devices, we have the component for action, measure and decide. So we only have a decision, but these two we don't have, right? So that's why we call open loop system. Okay, let me explain first. Okay, inside this open loop system, we have controller. Basically, controller is used to make changes in the system if needed. Like what I'm saying before, the controller is used to decide what we need to do. Actuator give an output of some action. So this actuator will give the output some action from the controller to change the controller output. So next, this is the process, the procedure or activity leading to result. So this process can be reaction, separation, heating and many more. And lastly here, output, the result of your work. The impact, the result of the system. Okay, basically our product, our end product is the output. So input here is what you need, your goal. So in input here is what we need. Okay, now moving to closed loop control system. So closed loop control system, also known as a feedback control system. So in here, control mode is on. There is a control system inside here. The reference to feedback simply means that the some portion of the output is returned back to the input to form part of the system excitation. After this, I will show the figure of this so that you can get the understanding. Closed loop systems are designed to automatically achieve and maintain desired output condition by comparing it with actual condition. So this one is set point. It does this by generating an error signal, which is the difference between the output and the reference input. So the difference between the measured variable just now and also set point. Okay, let us see. So this is the control and closed loop system. So it is the same as open loop, but the additional is there is a sensor for the measuring purposes. So we have a we have the here decision, here action. So complete all those three component, basic component for the control system. So in here, why we call feedback? Because this system measure something from the output and go back, send the error to the input. So that's why we call feedback. So like what I'm saying before, we have input here, and we have controller, we have actuator, process, output and also sensor. So from here, for example, we need the temperature here 100 degrees Celsius just now. T desired, our set point 100 degrees Celsius, and then the sensor will read whether the temperature going out from the process achieve 100 degrees Celsius or not. If not achieved, if the temperature is around 90 degrees Celsius, and then we will send the information to the controller. So input here is the set point that we set. This means we want 100 degrees Celsius, right? So what you need is 100 degrees Celsius temperature. So the controller will make a comparison, and will make the decision. Okay, in this situation, they want another 10 degrees Celsius to meet set point, and then the controller will ask actuator normally our final control element, which is valve, to do an action. So if the temperature is lower than the desired set point, and then the steam, just now the steam in temperature must be increased so that it will cater the deviation of the temperature inside the process. Okay, that was how the closed loop system working. Okay, so closed loop system use a measurement of the output and compare with the set point value to create the error signal, which is amplified by the controller. This is what I'm saying just now. How feedback control works. Feedback control is applied to achieve the desired set point by adjusting manipulated variable. So manipulated variable, remember just now, is steam in, right? Desired output just now is temperature out, 100 degrees Celsius. Okay. Sensor is designed to communicate with controller. So sensor will at first it will measure the process variable first, right? And then it will send the information, communicate with controller and final control element, and the control element will respond to the command from the controller. So in practical application, feed-forward control is normally used in combination with feedback control. So just now we learned about feedback control. So feedback control is because they measured from the output, right? And return back to the input. So that's why we call it as a feedback. Feed-forward is used to reduce the effect of measured disturbance, while feedback is used to track the set point changes to make the corrective action in order to compensate for inaccuracies in the process model, measurement error, and unmeasured disturbance. So I will explain in detail what is feed-forward, but for your information, so just now we have controller, we have actuator, process and output. So we have input. Okay. So feedback is like this, right? Sensor. Go back here. So feed forward the variable is measured at disturbance side. So for example, if the disturbance in here, so we need to measure here, connect with sensor, and then it will send the information in here, and then controller will take an action. Controller will decide, actuator take an action. Here goes the process, and then output here. So this input is our set point. Okay, so I will explain in detail what is the feed forward in the next slide. So this video we end up to here. I will continue the chapter 1.2 and 1.3 in the next slide. Thank you.